Hello and welcome to the Fossil Huntress podcast. Today we're going to talk about living fossils, and this comes from a question by Sayre Morgan, hello Sayre, who asks if brachiopods are technically still alive today and look similar and we can recognize them in the fossil record over 500 million years, why do they maintain their original appearance? And by this he means evolution has been a driving force, prey, predation, breeding, climate, and so on, but they seem unfazed. And so, Sayre, I sent you a little message on Facebook, but I'll bring it to a wider audience. When we think about the history of life on Earth and the vast changes that have transpired over millions and millions of years, so little single-celled organisms evolving into species, ginko biloba, dragonflies, humans, crocodiles, whales, and crayfish, like just crazy diversity. If you had to sit down and plan all those body designs, it would be a body of work. But among all that evolutionary change, some organisms have modified very little from their distant ancestors. So the example I give is a water strider, nailed it out of the gate. So just they haven't evolved or changed over time because we got the body plan right from the beginning. And right for something like a water strider or a horsetail or a shark or croc or duck-billed platypus has to do with their habitat and lifestyle. So if they remain so stable over time, then there is little evolutionary pressure to change. So that's sometimes true, and that's not entirely true for all those groups, but it's our perception of them. In things like brachiopods, there's 300 living species, so 300 types of brachiopods that we consider different in some small way, where they've niched themselves into an environment where they're perfectly adapted to it, or they'll continue to evolve until they're more perfectly adapted. So we have a perception of these species not changing, but the changes are subtle over time. In some cases, like the crocodylians, and when we look at a modern croc and we see a special on television, they often say, they're the same and they go back. They're unchanged since the time of dinosaurs. That's actually not strictly true. The crocodiles we see today are very small. They're still mighty, but they're diminutive in comparison to their ancestors. And they've been around for a long, long time, so they go back about 85 million years, all the way to the Triassic. If you do a little Google search of prehistoric crocodile evolution and then take a look at the images of a modern croc and going back through to Sarcosuchus, who's like just a beast of a machine, there are relatively big changes. So the popular media, may present a picture that there hasn't been much going on in terms of evolution. There's been quite a bit of evolution. So creatures like the coelacanth and duck-billed platypus, horsetails, velvet worms, cow sharks, lice. In some cases, it's the creature isn't on the earth long enough to radiate out in every way they could. But in the case where they're on the earth for any length of time and they need to outcompete in a certain environment, there'll be changes. They'll just be very subtle changes. So for our sweet brachiopods, they do evolve over time. One could consider them in the living fossil category because there's not a huge amount of change, but there are still changes. A really good example of living fossils would be the cow shark. So most living sharks, from nurse sharks to great whites, have 5 gill slits on a side, but there are 4 species of cow sharks that have 6 or 7 gills. So a feature thought to be retained for millions of years from some of the earliest sharks. So these deep water 6 and 7 gill sharks are considered some of the most archaic of all shark species. And a few years ago, I got to go scuba diving with them. And while they They don't come to shallow water very often. I was with a team filming them, and we went down to see them, and they are certainly archaic throwbacks within the lineage. So most of the evolutionary story of sharks is primarily one of teeth. And if you collect shark specimens or shark species, it's likely, when you say that, it's not the full body of the shark. You're most likely collecting the teeth. And with very rare exception, shark fossils can be preserved as soft parts, but it's usually all about the toothy bits of the shark. And their species, the shark lineage, goes back about 409 million years, and maybe even older. The lineage to which today's 6 and 7 gill sharks belong is more recent, so they go back at least 175 million years. And these deep water sharks are opportunistic feeders. So they take whatever they can, and they have a stable role as kind of the deep sea cleanup crew. So they're scavengers on the bodies of marine reptiles, and that behavior goes back to the Mesozoic. And then in more modern times, they shift to marine mammals after the time of the dinosaurs, but they're still scavenging, whether it was marine reptiles, so tasty ichthyosaurs and mosasaurs, or more modern mammals and whales. What they do and how they live and their behavior hasn't actually changed from being consumers of deep sea carrion for millions of years. And in their case, they are living fossils. Their body plans have not changed because their style of living hasn't really changed, even though the tasty morsels of food have been made up from different creatures. The way they make a living is relatively stable. Another great example of a living fossil is a horsetail, so a plant, not as sexy as a shark or a croc, but we still have them living on the earth today, and they reproduce and began this method of reproduction millions and millions of years ago using spores. And this makes horsetails very resilient and very difficult to remove from places where they're considered weeds today. So in their deep fossil record, they lived in forests and in swamps and near streams, and we can picture a dinosaur living beside them. As modern trees evolved. Horsetails used to be much, much bigger. So same body design, just different sizes of body design. So they used to be the size of trees. And around 360 to 300 million years ago, our carboniferous deposits, our coal deposits that we harvest today as coal that we burn for fuel, and they tragically still fuel our world. Those coal deposits are the remnants of horsetails that look very similar to what we have today. So species like calamites back in the day would have grown to 100 feet tall. So while horsetails are living fossils, they're only they're up to your knees today. So when you walk through horsetails, they're not that tall. They're certainly shorter than you. But back in the day, they were 100 feet tall. So the perception of them as being unchanged is not exactly true, but they're certainly very similar. Another great living fossil and also a plant are ginko trees. They're not quite as old as horsetails, but they go back about 175 million years. And today we see only one species, Ginkgo biloba, and my aunt and uncle on the island have a beautiful one growing in their yard. But this tree with its fan-shaped leaves, so it looks like two fans you'd use to cool your face. They're small, so a ginkgo leaf would be about the size of the palm of your hand. In their heyday, they lived alongside ferns and cycads, and they would have been snacked upon by the Jurassic dinosaurs that preferred to eat plants. So they're another great living fossil. one of our marine living fossils, and again, one of my favorite, are horseshoe crabs. So they have a big carapace and a long spine, and they look prehistoric. So we think that they sort of broke off from an arachnid cousin around 48 million years ago, but the basic body design of a horseshoe crab has remained relatively stable over time. So they're a really good example of sort of a creature that's made a living in the seas, and that environment hasn't changed too much of them, so they're able to kind of scoot along and move along to the environments that work better for them over time. I'm certainly simplifying that piece, but they lived through some mass extinctions and came out the other side, so that's quite remarkable for any species. So consider the other creatures, the dinosaurs and the ammonites that have all gone extinct. Through those catastrophic events, the horseshoe crab just carried on. So I'll do up a post on them as well, because they're a wonderful fossil and they're a great example of a living fossil. So back to you, Sayre, and the question of brachiopods. So there are about 100 different genera living today, and they're not as plentiful as they once were. We find them attached to kelp or clinging to rocks. I've collected them as fossils up in the Kootenay region of British Columbia. There are over 5,000 known genera from the fossil record, spanning about 530 million years. So by about 488 million years ago, brachiopods had become the dominant shelled animals in the sea. And they were, so sometimes we find them in coquina because they were just rich in some areas, so brachiopod heaven. And all that changed with the worst mass extinction of all time. So back in the Permian, that mass extinction had a catastrophic effect on brachiopod and the other planet's fauna. We still see them today, but they are changed, and there are around 300 different species living today. So they are considered a living fossil, but given the diversity, so 300 different types of brachiopods, they still had some niche building in there where they tucked into an ecosystem that best suited them. They've got some different body plans and different ridge types for whether they were in a little bit of surf or a lot of surf or just a bit offshore. So there's a tiny bit of evolutionary change in them by living fossil standards, but it's still enough to say that they evolved over time. Anyway, I hope that's helpful and a little bit of background and info on living fossils, and I'll talk to you guys all soon. Take care.